Hello class, this is section 2.1, Graphical Summaries for Qualitative Data. I'm your instructor William Buellman, and this is Stat 1200. So we have some objectives for this section. We're going to try and construct frequency distributions for qualitative data, construct bar graphs, and construct pie charts. So we have some definitions that we're going to go over. The first definition is frequency. The frequency of a category is the number of times it occurs in a data set. So how many times does it happen? So a frequency distribution is a table that presents the frequency for each category. So frequency distribution is just a nice way of presenting the frequency. Then we have the relative frequency. So the relative frequency is the frequency divided by the total number of frequencies. So the sum of all frequencies. So the way we're going to remember that is this formula right here. And finally, like the frequency distribution, we have a relative frequency distribution, which is just a table that summarizes everything. So again, the relative frequency distribution is a table that presents the relative frequencies. Often we combine a frequency distribution and a relative frequency distribution to make a nice table that summarizes everything. First example. The table below shows a list compiled by a retailer. This retailer accepts 4 different credit cards: Visa, MasterCard, American Express, and Discover. The list contains the types of credit cards used by the last 50 customers. So we can see we have Discover, Visa, American Express, Visa, etc. We are now going to create a frequency distribution to summarize this. So if we were to count the number of times MasterCard appeared in that list, we would see it was 11 times. Visa was 23 times, American Express was 9 times, and Discover was 7 times. So now we can see we have the frequency distribution right here because we have each of the frequencies. So again, to remind you, relative frequency was the frequency divided by the total number of observations, or the sum of the frequencies. So since we know there was 50 observations, the relative frequency for MasterCard is 11 divided by 50. For Visa is 23 divided by 50. For American Express is 9 divided by 50, and for Discover is 7 divided by 50. And for each of these, we're going to find the decimal equivalent. And the reason why we do that is because often with relative frequency, we work with decimals because it's easier to compare decimals and graph them than it is to graph fractions. So those are the decimal values for each of the relative frequencies. Here we have some more definitions. So a bar graph is a graphical representation of a frequency distribution. A bar graph consists of rectangles of equal width, that's important, equal width, with one rectangle for each category. The heights of the rectangles represent the frequencies or relative frequencies of the category. So we can use a bar graph for either frequency or relative frequency. Sometimes it's desirable to construct a bar graph in which the categories are presented in the order of frequency or relative frequency, with the largest category first, then the second largest, third largest, etc., and the smallest one is on the right. When we do this, we call this a Pareto chart. So where you see this most often is typically like in elections or something like that, where in order does matter and you want the highest to be most clear and easiest to see, versus in a typical bar graph, the highest one isn't always the first one, and it can be a little bit harder to see who's leading or who's winning. So in this example, we're going to create a frequency bar graph and a relative frequency for the credit card data. And make sure you always label your graphs. So I'm going to go ahead and do that right now. Okay, this is going to be MC. We'll call that MasterCard. Right here is going to be Visa. AM for American Express. And D for Discover. So if you remember right, MasterCard had 11. So we're going to go up here, and that's MasterCard. Visa had 23. American Express had 9. And Discover had 7. So that's what the frequency chart would look like. So now I'm just going to show you guys the relative frequency, which you'll see in a second. So you see here, this is what the relative frequency would look like. And if you look at the frequency and the relative frequency, you notice they're very similar in look, just the y-axis is different. In the frequency, it's a whole number, where in the relative frequency, it's a decimal number. Next, we're going to work on a Pareto chart. So remember, a Pareto chart is just organized from large to smallest. And in this case, we're doing it for relative frequency. So I will create that graph and you will see it in one moment. So this is the Pareto chart for the relative frequency. Do you notice something different on this chart than the other two? Besides the fact it's a Pareto chart, you'll notice I labeled the axes. And you need to make sure you do that as well. Not only do you need to give every graph a label, you need to give the axes a label too, so we know what they are. V, MC, AM, and D don't tell me much unless I know, oh, it's the credit cards. And what is 0.1, 0.2, 0.3? None of that helps me any. So I need to label that axes so that way I know, oh, that's a relative frequency. So this is going to be a practice for you guys. This is aircraft landings that occurred at a small airport. So you notice you have twin, single, helicopter, turboprop, jet. So these are all the types of engines that these aircrafts have. So what I want you to do is I want you to construct a relative frequency distribution for the data, construct a bar graph distribution for the data, and create a Pareto chart. So the answers will begin in 3, 2, 1, now. Here we have the frequencies and relative frequencies. So if you go back and you were to count them, these are the answers you would get. So now we're going to go into the bar graph and Pareto chart. So here we see the frequency bar graph. TW stands for twin, TP stands for turboprop, and you can see how each bar goes up to the frequency. And next we will have the Pareto chart. Now we see the Pareto chart of the frequency. We just have it from, again, largest to small. So single, then twin, then turboprop, then jet, then helicopter. Here are some more bar graphs. So not only do we have them vertically, but we also draw bar graphs horizontally. Usually we do this when we have very long titles, and it would be very hard to draw it vertically because the title's so long we'd have to space the bar graph out very far apart to be able to see anything meaningful, versus with this, since these titles are very long, if we write them horizontally we have much more room and it's much easier to do that. So I will show you that next. So now I have everything set up. If you've noticed, I've only used the first words of each category just to make it easier. So we do farming. If we look back, it was 0.007. So that is very small, like that. We can even fill it in if we want. Sometimes that makes it easier. Next we have manufacturing, which was 0.230. So I'm going to go over to about 0.2, slightly a little bit more. And again, sometimes if you fill it in, it makes it a little bit easier to read and see. So managerial was 0.373. So we're going to go past 3.5, about halfway to 0.4. And again, fill it in. Sales is the next one, which was 0.242. So almost 0.25. And finally other, which was 0.176. So between 0.15 and 0.2, which is about here. And we'll fill it in. So that is a horizontal bar graph. And we can see this is better because we have long titles, so it makes it much easier to squeeze them in there. If I was trying to write the full titles, you can see how this would be even better because of the amount of room it would take up to write the full title. Another type of bar graph we use is side-by-side bar graphs. So this is where we have two sets of bars side by side. And the reason why we'll do this is usually when we're comparing times. Like in this case, we're comparing the same thing in December of 2011 and December of 2012. So we're tracking the number of visitors in millions between December of 2011 and December 2012. So we want to see for Google, Facebook, Yahoo, YouTube, and Wikipedia, how much have they changed in the number of viewers per year. So that's where we use side-by-sides when we're comparing things. So here I will again show you the side-by-side bar graph. So we can see what happened over the years. We can see from 2011 to 2012, Google's number of views went up, Facebook's, Yahoo's, and YouTube's, while Wikipedia's went down slightly. On these, when you're making graphs, it's kind of hard, so I'm not looking for perfection. I'm trying to see, do you understand the idea, and not is it exactly perfect. So you just want to show a general understanding. It doesn't need to be perfect. Another way we like to show data is called a pie chart. So a pie chart is an alternative to a bar graph for displaying relative frequency information. A pie chart is a circle, like a pie, that is divided into sectors for each category, and the relative size of each sector matches the relative frequency. So we can see here that Visa was approximately 46%, so it should be about half of the pie. So it needs to roughly make sense. Again, it doesn't need to be perfect, but it needs to roughly make sense. So pie charts, you probably won't be making too many in this class, but it's a good way to see data. When you do make them, you usually use software, something other than, making them by hand. Here we have a third example. The most common blood typing system divides human blood into 4 groups, A, B, O, and AB. The following bar graph presents the frequencies of these types in a sample of 150 blood donors. So we see there was 60 people that had type A, about 15 people that had type B, 70 people who had O, and 5 people that had type AB. So we're going to answer these 3 questions. Which blood type is the most frequent? Is it true or false that more than half the individuals had type O blood? And is it true or false that more than twice as many people had type A blood as type B blood? So we're going to use the bar graph to answer all of these. Looking at the bar graph, we see that the most frequent type was type O. So it asks us, is more than half of the individuals type O? Well, we saw that there was 70 individuals that had type O out of 150 people. So if we were to do the math on that, 70 out of 150, is that more than 0.5 or is that more than a half? And no, it's not. So this is false. More than twice as many people had type A blood as type B blood. So we saw the amount of people who had type A looks like 60. The amount of type B looks like 15. So is 60 more than 2 times 15? So is 60 greater than 30? Yes, it is. So this is true. Here you're going to do some practice. So the following is a side-by-side bar graph that represents percentages of the source of funds for food expenditures in the U.S. in 1940 and then 2012. I want you to answer these 4 questions. Which sources of funds for food expenditures increased as a proportion from 1940 to 2012? Which source of funds of food expenditures decreased as a proportion of the total from 1940 to 2012? In 1940, the smallest source of funds for food expenditure was governments. Is it still the smallest source in 2012? In 1940, the largest source for food expenditures was families and individuals. Is it still the largest source in 2012? So go ahead, pause the video here. Answers will be displaying in 3, 2, 1. Here are the answers. Which source of food expenditures increased as a proportion from 1940 to 2012? And that was families and individuals. Which ones decreased? Produced at home was larger and now it decreased. In 1940, the smallest source of funds for food expenditure was governments. Is that still the case? No, if we look now, the smallest source is produced at home. So the largest was in 1940, families and individuals. Is it still the largest? If we look, yes it is, because that bar is much larger than all the rest still.